Hi all, this is Ayan. Greetings for the day. So in our previous lecture, we had explained to you how to create your AWS platform and how to go to the notebook. And I'll be giving you a quick recap of it. Okay. So just a quick summary of what we did in the previous class. So we went to AWS Management Console. So you went to AWS Management Console after creating your account and logging into it into AWS. So we go for services, and as I remember, as far as we are concerned, we will be using Amazon SageMaker, S3, and EC2 alone because the other services might start to charge you. So be careful. Make sure you use only these three for our course. And then we went to Amazon SageMaker and we opened the SageMaker Studio from here. So this is where you open the studio and this is how your studio looks like. Okay. So from here we are creating a new notebook and this is the notebook for today's lecture. So in today's lecture, we'll be covering the various aspects of Python. We'll be telling you about data types. We'll be telling you about other tokens and variables and other features which are available in Python. And before we start, let me give you a brief intro of Python. So we have a PowerPoint for that, and we will be sharing this to you as part of the course material. So Python was introduced in 1989. It is a versatile, widely used, and a very easy to learn language. So if you're new to programming and you're scared of things like semicolons or curly braces, so Python is a good way to start. If you're new to coding, I would highly recommend Python. So it is quite easy to learn and it makes things a little simpler. So Python has gained a lot of popularity over a large bit due to the versatility, due to the presence of a large number of libraries that help you out in easy executions. So that is what makes Python popular. And as you will see through the course, it makes it very simple for you to apply some of the complicated algorithms. So as we go through the lecture, I'll be running you through the slides. So I'll be giving you the summary of everything that is there in the slide and all the major requirements that will help you to code in Python. So to start with, let's go from fundamentals of Python. So the first thing to be taken into consideration is tokens. So what is a tokens? Token is the smallest lexical unit variable in a program. Now that is a little complex, so I'll make it simple for you. So what is a token? So if I write a is equal to 50 here, so this is a token. Okay. A is a token, equal to is a token, and 50 is a token. So each element that you write in a notebook, that is a token. Okay. So as simple as that. And then there are different types of tokens that we'll be working on. We'll be working on identifiers, delimiters, literals, and operators. So as we go through the course, I'll be taking you through these things and I'll be explaining each and every aspect of it. So let's begin with. There is one of the most important characteristics in Python. It is called dynamic typing. Now, guys, for saving some time, I have prepared a notebook, but don't worry about it because I would be executing some of the codes myself to make you understand it clearly. Okay. So let's go with the first aspect of Python, which is called dynamic typing. Python is a dynamically typed language. Now, what does that mean? So let's go with, let's say, we assign a value of 50 to the variable a. So that is done here. So a is equal to 50. And then if I print a, so you get 50, right? This is the desired output. Now let's say throughout the program, let's say there is a very large program. So at certain point of time, we assign a new value to a. So now we'll assign a value of 250. Okay. So now let's again print a. Okay. Now if you see this cell, in the same cell, I have mentioned that a is equal to 50 and printed it. Then again in the next line, I have mentioned a is equal to 250 and I have printed it. So let's see what happens. So if you run this, so as you can see, it prints 50 and 250. So how did this happen? So A gets a value of 50 here and we print A. So 50 is printed. Then again, we assign 250 to A and then print. So 250 is printed. So this is called dynamic typing. Now, what it means is that if you change the value of a variable in the next line, and if you print again, the value taken by the variable changes without throwing any error. There won't be any error in this. Okay, they would not throw any error. So in this case, we have used the same data type, but in the above example, that is the first one, you can see that initially I have mentioned a as a number or an integer, and then I have mentioned a as a string. Okay, so this is a different data type. This is a completely different data type. So if we run this, so as you can see, the same things happen here. So as you can see, the same things happen here. So what does it show? So it shows that a variable can take any value. It can change the value that it is taking in the previous line. It can change from number. It can change to any data type. I can even change it to another data type. Let's say I change it to a Boolean data type. Okay. And if you're getting confused with the data types, don't worry. I'm going to explain that in detail moving forward. So don't worry about it. So as you can see, in this case, again, after 50, we assigned it a Boolean value and it had taken a Boolean value. Okay. So this is called dynamic typing. Now, if somebody, for people who are new to coding, this might not seem very fascinating, but those who have maybe have a little bit of background in coding, they would remember that in other languages like Java or C Sharp, you have to mention like, for example, if I have given a value of 50 to A, I have to mention that it's an integer. Okay. Similarly, in case of this, I have to mention that it's a Boolean value. So that is not the case with Python. You don't have to do it in Python. You can simply assign any value you want. So this is the concept of dynamic typing. Now, also, one has to remember that Python is case sensitive. So what that means is, if I say, if I assign a variable, suppose I say, let's for simplicity, let's keep it as A itself. So I say A is equal to 253. And then if I say print, and let's say instead of small a, you give a capital A. Okay. And if you run it. So as you can see, an error, it throws an error here because the small a and capital A are not considered same in Python. So please remember that Python is case sensitive. Whatever name you give to a variable, make sure you put the same name. Okay. Don't expect that if you put a capital A, it might mean the same. Okay. So same goes with anything. If it's a underscore B, and then here if I try to print AB, okay. So even in that case, it will throw an error. So you have to make sure you, whatever name you put here, you have to put the same name here. So be careful about that. That is an important step. Now, moving on, we will be explaining you the operators. So what is an operator? An operator is a symbol that indicates a mathematical operation. Okay. So for example, obviously plus, the plus sign for addition, the minus sign for subtraction, the star in this case for multiplication, and the slash for division. So these are the various operators. These are the basic operator which you are very familiar with. So I can simply show you that how addition, subtraction, and all is done. So just I'm declaring two variables and I'm performing the basic mathematical operation. Nothing fancy here. It's very simple. Now let's move on to some other operators which are available in Python and which are extremely helpful. So let's say I ask you that I'm giving you a number. So I'm giving you a number, a simple one, not a very complicated one. I'm giving you a number 16. Okay. And I tell you that you're going to divide this number by B, which is, let's say, 3. Okay. Now you're going to divide the number. So the quotient would obviously, you will easily find the quotient by using this operator, right? But I don't want the quotient in this case. In this case, I want you to print the remainder of it. Okay. So if you divide, what would be the remainder of the operation? So what you can do in this case is you can use the operator called modulo. Modulo is indicated by percentage symbol. So you can put A, the percentage, which will indicate the modulo, and B. Okay. So A modulo B would give you the remainder of the operation. Okay. So it's giving 1 because it's 3, right? So 3 into 3 multiplied by 5 is 15. And since we are dividing it by 16, we'll have a remainder of 1. So you get a remainder of 1. Okay. So this operation is very helpful in Python because often, they might ask you things like, is the number even or is the number divisible by 3? So in those kind of cases, you can use modulo. So how can you use modulo? Suppose it's a large number. Okay. Suppose it's something like this. And then they ask you, when you divide it by 3, is the number divisible by 3? So how do you do it? You can simply do a modulo b. Okay. You run it, and it's taking some time, I think, was the large operation. I'll reduce it. Yeah. So if you run this, okay, I think, I'm sorry, the kernel has to be restarted. I'm sorry. Right. So here we go, and we run this again. The kernel is still starting. So modulo operation helps you a lot when you have requirements of finding out whether a number is divisible or not. So if a number is divisible by the given number, obviously the modulo will give you a 0, right? Because there will be no remainder. So that is where this modulo operator helps you out. Okay. So similarly, I have given some more examples as well, which you can try yourself. Now the next operator, which is very helpful, is called the integer division. So what is an integer division? So let's say again we have a number. So I'll keep 100, and we are dividing it with, say, something with which it's not exactly divisible. Okay. So let me divide it by 6 maybe. Okay. And let's divide 100 by 6. Okay. So we're going to do 100 divided by 6. Okay. And we run this. So as you can see, we get 16.666, right? But let's say in your requirement, in your output, you want a whole number. You don't want a decimal value. So what you can simply do is, instead of a single slash, you can use a double slash. So this is called integer operation. Okay. So let me run it to show you what it actually does. So it makes sure that the output is a whole number. This is a very important operation because it would help you out to remove the confusion that is caused by decimal points. So if you don't want decimal points, you can simply run this and you can get without decimal points. So let me show you one more example here. So this time we are dividing 10 by 3. Okay. So single division, single slash, we get 3.33. And if you put the double slash, simply you will get just 3. The decimal part is removed. So this is called integer division. Okay. And just to be very clear, this is not a rounding off. Okay. So they are not rounding it off, they are simply just removing the decimal value. So if you see here, if I perform this operation again with a single division, it's 16.66. Okay. So logically, if you round it, it should become 17, but that doesn't happen because that is not what it does. It just removes the decimal value. That's all it does. Okay. So don't get confused with that. Now, moving on to the next operator. So it'd be working on the operator called exponent. So how does the exponent work? So exponent is nothing but a power b. So if I use the same example as above, let me take a and b here. And so what I'll do is I'll just put a. So exponent is shown by double star, a double star b. Okay. So this is how you get the exponent. So as you can see, 10 to the power of 3, that is 1000. You get 1000 here. So this is the exponent operator. So as usual, I have given other examples like, finding out the 2 to the power of 3 and then 12 to the power of 2. Okay. And suppose you want to find out square root of a number. Okay. So you want to find out square root of 144. So what you can simply do is, as mentioned here, I have put, let's put a is equal to, okay, instead of 144, since we already know it is a perfect square, okay, let me show you an example with that first. So let's just print a exponent. And how do you describe the square root? You can simply put a to the power half, right? So if you run this, you get a 12.0. Okay. So it will give you in form of a float to 12.0, right? Now, this is a whole, this is obviously a perfect square number. So I'll show you an example for which is not a perfect square number. Okay. And you run it. So you can get the accurate square root value. Okay. And you can, similarly, you can also do a cube root. How do you do a cube root? You can simply put, instead of 1 by 2, you can put a 1 by 3. So that would help you do the cube root of it. This is the cube root. Okay. So this is how you can use exponent. This is a very important operator. Now we will be moving on to data types. Okay. So one of the important function that you can use for finding out the data type of a variable is type. So this one, it's the type. So this is how it works. You declare a variable and you just print the type of the variable. And if you run it, so integer, right? So what is an integer? Integer is nothing but a whole number. So for example, 50 is a whole number, right? So 50 is an integer. Now let me put something like 50.25. So what is this for Python? As per Python, what is this? So this is a float. So a decimal value, right? If you have a decimal value, it's a float. It's not a whole number. Now, if you're confused about symbols, let's say I put a minus symbol here, okay? And let me just run this. So it will still show a float. It won't be doing any changes to that. So even if I run it like this, it would be showing an integer. It won't be showing something like positive integer or negative integer. So that's one thing that you have to take care of. And next data type is string. So what is a string? String is a chain of characters. So it can also be it can be a single character or a chain of character. Okay. So if I have just s here, that is also a string. So it's, as you can see, it's showing str. If I have a star here within the quotes, okay. So string is always shown by these quotes. Okay. If you have quotes around a variable, it's around a constant, it's a string. So as I'm mentioning, b is star. So let's just find the type. So it's a string. Now to show you, if you put a number within quotes, okay, so it will still show a string. So make sure that if you're using quotes, it is a string. Just keep that in mind. Okay. So this is the float that I have shown you before. So now let's move on to another data type, which is called Boolean. So Boolean takes only two values, the true and the false. Okay. So if I mention D as true and R as false here, and if I simply put the type of D, you can see it's showing a bool. So that is the Boolean value. So true and false are Boolean value. So I can just show you for R as well. Okay. So that is a Boolean 2, right? So, similarly, I have given some more examples here. Okay. So as you can see, there are different examples that I have mentioned here, right? So after this, we'd be moving on. Since we have explained you the data types, we'd be moving on to the concept of typecasting. So what is typecasting? So let's say I give you a float. Okay, I give you a float value. So I'm giving you a float. So I'm giving the same one, 50.25. Okay. But you want to make sure that you do not have a float in your operation. You need to take integer value as your constant. Okay. So we do not want to take in a float value. So in that case, what you can do is you can just use the keyword int. Okay. So int, and you can put float number, right? And if you run this code, what happens is the float is changed from 50, it's written as 50.25, right? So it will simply make it 50 and it will convert it into an integer. So let me show you that. So if I print, so let me show you what we had initially. So initially we had mentioned the float number and then we typecasted it to an integer. So here you go. And if we run this, so like I mentioned, the float is converted to integer. This method is called typecasting. So now just to show you that the type of data type has been changed, I'll just be printing the type of both the outputs like this. And if I run it, so as you can see, the first one is a float and the second one is an integer. So this is the method of typecasting. Okay. So let me give you some more examples. Since we have done it for float and integer, let me show you for string as well. So let's say you're given a value which is a string. So string, as I had mentioned, and it will be in quotes. I say 125, but you want to take the input as an integer. So what you can do is we can just simply type. So I'm finding the type. We are finding if the type is changing, right? So int. Yeah, let me mention it this way. So integer equal to, simply put an int keyword again and the name of the variable. Okay. And we'd be printing the type and we'd also be printing the value. Okay, there you go. So as you can see, initially it was a string. Now it has been converted to an integer. So we are printing the integer value, right? If you want to see whether it has changed or not, you can I'll just show you. It's a string initially. Okay. So when I put the string num, it's a string. And when I put an integer, it has been typecasted to an integer. Okay. Now, just to show you what happens if instead of a number inside we put, let's say, a name. Okay. And let's run it. So you get an error because a character cannot be converted into a number. Okay. So that is the logic. That's why you're getting an error there. So this is what happens. This is what happens if you put a character inside instead of a number. So let's do the other way around. Since I have converted string to number, let me show you how to convert number to string. So this operation is also very helpful at times if you want to concatenate, create IDs or something like that. This operation is very helpful. So what we'll do is we write something like this, integer, and then we convert it to a string. So that would simply be str bracket integer, right? We put it up like this. And again, we'll be printing the type of the first variable and the type of the second variable, right? So if you do this, you would see that initially it was an integer, then it has been converted to a string. Now this operation can also be performed for Boolean values. Okay. So for example, if you go here, as you can see, I have, mentioned Boolean values, A as true and B as false. And let me convert them to string using the str operation. So if you run, it will convert to string. Now, if you want to convert it to an integer, suppose, let's see if that works. Okay. So if you run, so as you can see, true would be converted to 1. Similarly, false would be converted to 0. So a Boolean value can be transformed into an integer, but can it be transformed into a float? Let's see. So if you run this, So as you can see, a Boolean value can be typecasted to an integer and a float. Okay. So, so the Boolean can be typecasted to integer, float, and string. Integer and floats can be typecasted to strings. Strings with numerical characters alone can be transformed into integer and float, but with string with the alphabet characters or symbol cannot be converted to string, cannot be converted to the integers. So as you can see, even the float value can be converted. You can see this way. So what happened? Oh, sorry. Okay, I'll just write it down again. So we cannot convert this to integer because it is not. I have made it a float, right? So you cannot typecast to an integer. So you have to write a float here, right? And you can run it. So you can see it has converted to float, right? So this is how typecasting works. Now, before we move on, in the upcoming classes, you would find questions where we require you to take input from the user. So in that case, you have to use the function called input. So this is how it works. So in these cases, I have mentioned that A is true, or A is some value. But in that case, we would be taking input from the user. So what you do is we write A is equal to input. Okay. So if you do this and if you run, you get a box here and you can put some value in it. So you can put 125 and you can press enter again. So now A has taken the value of 125. So if I print A, you get 125. Okay. Similarly, again, if I run this and if I put a string, let's say Ion, and again I press enter, and then if I print A again, you can see it has taken the value of Ion. Now let's do a simple operation. Okay. So you'll be given the task that you have to take an input from the user. You have to multiply that by 2 and print out the product. Okay. So I'll be taking an input from the user. So the first step would be taking input from the user. So that is user input. So that would be taken first. So this is a very interesting application. You would find it very interesting. So let's take user input, and then what we are going to print is we are going to print the user input multiplied by 2. Okay, quite an interesting operation. So let's run this. They will ask for the input. I'll give an input and I'll press enter. So what has happened here? So is 125 multiplied by 2? So is 125 multiplied by 2 this value? It's not, right? So what has happened? So let me show you what is the type we are getting. Okay. So instead of doing a mathematical operation first, let's find out the type of it. So type again, and we can put user input type, right? And let's see what is the type it takes. Okay. So again, I'm going to put a number, right? Enter. So what is the input type? So it is taking string, right? So that is the reason you're getting that kind of an output for that operation. You cannot, if you take input, it will always come in form of a string. So this is where the application of typecasting, you'll see the application of typecasting. So what you have to do is if you want to multiply this by 2, you need to make sure you typecast it to an integer. Then you multiply it by 2. Only then it would work. Okay. Only then you would get the desired output. So I'm putting the same number and you can see. So this time it has multiplied by 2 because we have typecasted it. So this is the most important application of typecasting. When you take an input from the user, it will always be in form of a string. Okay. So please keep that in mind. When you're taking input, you have to always typecast it, right? So this is an example, and I have put some more examples here, as you can see. So this is an example where we are adding actually. So say if you're adding, and let's take an input again. So I'll take 52, I'll press enter. So in this case, in the first step itself, we have converted it into an integer. So if we use that variable to add to a number, it would work for us, right? So make sure you do that when you take input. And one final application before we close this lecture is rounding off the number. So as I had mentioned earlier, you might get a number something like this, and maybe you want to get it in 2 decimal places alone. So this is how it would work. So if I run this, you will say 258.82. Now, as I had mentioned previously, that this is a rounding operation. So in this case, the proper rules for rounding off is followed. So since it's 1 5, it would become 8 2 because there's a 5 here, right? So the next one would be changed to the from 1 it will be converted to 2. So that's what has happened here. So this is round operation. So it takes two values. Round operation takes two values, the variable that is a here and the number of digits to which you want to bring it. So if you want to bring it to 3, you can just put 3 and you can run this again. So it has been converted to a 3 decimal place. So this is about round operation. So in today's lecture, we have shown you the application of various tokens. We have shown you the types of variables, data types. We have mentioned and we have explained to you dynamic typing nature, case sensitiveness, various operators that are being used in Python. And we also showed you typecasting and also taking input from the users. And finally, we ended the lecture with a rounding operation. So these are the very basic requirements of Python. As we move forward, you will see that they are used at every step. So make sure that you're familiar with all this, keep practicing this, and we'll be sharing this notebook to you as part of course material so that you can practice from this as well. So thank you so much. And I hope to see you in the next class where we'll be explaining about the data structures which are being used in Python. So thank you and see you in the next class.